So this is the basic training for robot operating system. So here, this is the type of software platform, so which is dedicatedly used for developing the robotic projects and products. Before going to involved in robot operating system, I use robot operating system for developing in any kind of projects or any kind of basic hands-on. So you should know the why we go for robot operating system. What are the history of robot operating system? You should know the basic terminologies which is mainly available for robot operating system. So you should know following these things before going to work on robot operating system. So a robot operating system is a type of platform. It's a robotic platform. So it can be involved in the for developing certain robotic projects. In robotic platform, while considering a robotic platform, we have two different platforms under this category. So first one is software platform, another one is hardware platform. So in the software platform, the robotic operating system come into the picture, that it will helpful for developing a robotic project. So it is a type of a software platform. We can use a robot operating system in this platform. So you should have some basic knowledge on the Linux system. So Linux file system, you should know those commands. So by using those commands, we can use robot operating system to develop a particular application in the robotics. So here, the robot platform can be divided into these two categories. First one is software platform. So in the software platform, we are using a robot operating system. So it is mainly helpful for providing such a features like hardware abstraction, low-level device control, sensing and recognition, SLAM algorithm for mobile robot navigation, and package management. So here, a robot operating system mainly uses the variety of packages. So those packages are mainly used for developing a robotic application. So if you want to integrate a certain hardware to the robot, this package is mainly used for those integration. So if you want to use sensor for sensing the environmental condition, if you are using a camera, so those data can be get from the corresponding device is mainly with the help of using the corresponding packages. So if you know how to use those packages for particular hardware, it will be helpful for you to develop a certain robotic application. So the package management is a major important thing in robot operating system to develop a robotic application, and we should have some knowledge and libraries and dependencies used in the robot operating system. So these are the software platform features are available for robot operating system. So initially, before going to know about robot operating system, so every robot having a software and hardware. So now we have some basic description about the hardware platform. So here in for developing a robotic application, so robot may be classified into serial robot or mobile robot or drone or underwater robot. So these it has wide variety of classification. So in our robotic field, we have wide variety of robots are available. So in order to develop those variety of robots, every robotic product consists of the mechanical part and sensor part, hardware controller part. So these each and every hardware parts are necessary for integrating those parts with the help of the mechanical fabrication or electronic circuit assembly. So you can develop a particular robot, but how the robots will do certain tasks, you have to program those robots with the help of any software platform. So hardware platform is mainly developed to perform a task, the task which we are giving. If we want to handle for some materials, like we can place our material handling application, welding, painting. For those application, that is those applications are we have to use robot for those application in order to reduce the human risk, and also it is a repetitive task, so it is very very boring task. For that, the robots are widely replacing those tasks. So here, without hardware, we cannot perform those tasks. So hardware is most necessary. So hardware, in hardware type, in robotic platform, in hardware type, we can classify into 4 different ways. So first one is mobile robot, and articulator, that is a arm type robot, and underwater robot, and another one is unmanned aerial vehicle. So these are the 4 general classification we have. We have it for robotic field. So for performing, if you want to carry out some tasks with those robot, we have to develop a software application. So for those software applications, we are using a robot operating system. So without robot operating system, we can perform tasks with the help of robot. So there are a variety of companies are available so we have in industrial robot, we have Fanuc robot, Yasakawa. So we have variety of ABB robots, Honeywell robots are available, Hyundai robots. So a variety of robots are available, but they have, if particular industry develop a particular robot, they have their own software. So we cannot modify any software. So in earlier days, in research for the research work, so that there is no separate common platform which is dedicatedly available for academic person. So for that, the robot operating system is widely used for helping those academic research work. But later it will be transformed to developing a real-time products. So here in India and some of the country, we are having a robot operating system. So apart from those countries, we have few countries are using a robot operating system in some other name, OpenRTM, Opros. So these are the platform which is similar to the robot operating system. So used in the European countries and China, etc. So ROS is nothing but a robot operating system. So it is not a operating system. So it is we can call it as a meta operating system. So the robot operating system is a meta operating system. It is like a framework. We can call it as a framework or a group of package. So you should not. So after this class, we came to know that what is meant by package. But package is the set of functional program. Okay. So those those software applications or software programs are combined together. So the group of packages are developed on the top of the robot operating system. So here we have operating system. Generally, we have operating system. Windows, Linux, Mac OS are available. These are the common operating system we already know. But ROS is nothing but a framework or a set of platform which is running on top of the main operating system. So that is why we can call it as a meta operating system, is ROS. So why we are using ROS here? What is the necessary for using ROS? So in earlier days, the researchers, academic persons are having they face very difficulty in carry out the certain research work. So if you want to develop or if you want to create some innovative work in robotic system, so in generally robotic system having variety of parts, variety of robotic softwares are available, variety of functionalities, variety of drives are available. So for considering a single robot, we have variety of parts, drives, and softwares are available. So if you want to carry out some innovative task in particular robot, we have to reframe the entire already which is available. If you want to control a mobile robot in autonomous, so you have to build same mobile robot from scratch itself. So from the scratch, you have to develop the same mobile robot, and one by one you have to move those application into as an autonomous robot. So if it has very difficulty to carry out the work in scratch. So for that, robot operating system is widely used. It will helpful for using the predefined package which is already available. So if there is if you want to plan, if you want to do your work in path planning, so you don't know about the controlling motors and function of the sensors. So you don't want to develop a application software for sensors and controlling part. So those parts, if you have readily available, so those software packages are readily available. You can use those package in your hardware system. So you can focus it only for developing the path planning. Okay. So if you want to go for navigation, autonomous navigation, so the path planning is not necessary. So here, yeah, you can use general path planning algorithm as a one set of package which is readily available. So the ROS will provide those opportunities. So ROS robot operating system have variety of packages for different functionality of robot. That is path planning, SLAM algorithm, obstacle detection. So for every type of robotic operation, there are certain packages that are readily available in the community platform. So you can use those packages and you can do some innovative work in that in your project. So for that purpose, ROS system is an open source which give that kind of flexibility. So you can use readily available package and you can do some modification. You can carry out an innovative task. So it will help those kind of thing. So now we move on to the history of ROS. So in the earlier days, in 1992, Eric Berger and Keenan, these are the two PhD students. They have developed one open source software platform for robotic field. So initially they have created a robot operating system. So they have to test those functionalities. So here they have developed certain packages for carrying out certain task in robot. So those packages should be implemented in certain hardware. So initially the RR robot. So this is the RR robot. So these RR robot are in those days. This is the famous mobile robot which is widely used for research purpose. So they have purchased this robot and they have used it for developing their own software package that is called a robot operating system. So Willow Garage is a company concern which is mainly used for developing our robot operating system and its packages. So initially they have implemented their own package with the RR robot. So initial days, this RR robot is mainly helpful for developing a robot operating system initially. So they can using ROS, they can model this same RR robot, and they have developed all kind of package like navigation, sensing. So those packages are readily available. So RR robot having wide variety of packages, since it is the first hardware platform which is tested on robot operating system. So Willow Garage is a company which in the earlier days they have worked on robot operating system. So here, once robot operating system have developed, so they have increased their package and community support in every year. So initially the ROS 1 was released in Jan 2010. After that, variety of distributions came into the robotic field in every year. So here Box Turtle. So these 2010 to 2012, those ROS distribution is only for Turtlebot. So Turtlebot is mimic of mobile robot. So it looks like a turtle. The simulation, it provides a simulation. Okay, simulation for mobile robot. So using those simulation in a robot operating system, you can develop an application program to operate the Turtlebot in real-time environment. So if you want to move the Turtlebot in any of your direction, if you want to move the Turtlebot in circle, spiral motion, you can develop those kind of application using ROS software. So it provides a cross-platform. So that is the one thing. ROS is mainly used for giving the predefined packages. Using those predefined package, you can develop your own work. Okay, so you don't need to develop your project from scratch. Okay, scratch. So here, if you want to develop a mobile robot, autonomous mobile robot, so some functionalities are already written as a program or application as a package. So you can use those package, you can do some modification in those package, you can develop a new program for a mobile robot. So same way, there are variety of packages are available. So that kind of support provided in robot operating system. The another thing, robot operating system is having a better future. It provides wide variety of support. So community supports are available. So if you want to develop, if you want to work with the robot operating system, so if you are stuck with any error or debugging, so you can directly ask with the developers, ROS developers, which is they can help you to get out from your errors. So later that July 2014, the ROS Indigos are released. So here the ROS Indigo provide most advanced packages that are available for mobile robot, and as well it has a variety of packages for industrial robots. So recently in 2016 to up to 2019, the most famous distribution in robot operating system is kinetic distribution. So it is widely used for ROS perception. So there is a, if you want to use a camera for detecting obstacles or object tracking application, you can use a kinetic cam. So after kinetic cam, the recent distributions are melodic and noetic. So these two distributions are recently used, and it has support. It has more support compared to kinetic. So here, kinetic having a wide variety of community support, but it will be ended in 2020, 21, I think. So, but we have in future we have melodic and noetic. So it has a wide variety of support, and we can use it for longer time. So after that, the ROS can be transferred into ROS 2. So in ROS, it has less stable, since if you are using a real time, if you want to use ROS for developing a real time application, it creates some error. Okay, so the speed will be very less, and there are some functionalities error available in the ROS. So if you want to implement your innovative work as a real-time product, so you have to go for ROS 2. So it is a stable. So as we already know that a robot operating system is not an operating system. It is a meta operating system, since it is a type of platform or a group of package which is built on the top of the operating system. So using so here the main operating system is Ubuntu. So inside the Ubuntu, you can install the robot operating system distribution. So using ROS distribution, you can develop a certain package for your robotic application. Okay, so here you are following the same features. So if you know how to use Ubuntu, you can work with ROS. Is very simple. So you can use the same command which we are used for Ubuntu. And there are certain commands were dedicatedly used for robot operating system. So you should know those commands. So using those commands, you can execute, and you can develop, you can modify your files in the robot operating system. So the functionalities are common to the ordinary operating system. There is a Linux-based operating system. So ROS type. So that is why we can call it as an operating system. But it has certain features like hardware abstraction, low-level device control, implementation of commonly used functionalities. That is, if you want to use a camera, you don't need to install a driver. So if you just connect your camera to the CPU where you have installed ROS, the camera is already automatically enabled. So the driver is already used with ROS. So if you want to use ultrasonic sensor to detect the obstacle, so no, you don't need to write a code for sensing the distance. Okay, so already the ROS has a dependency. Using those dependency, we can integrate the ultrasonic sensor to sense the distance. So there is a commonly used functionality, message passing between the processes. So here message passing between the process is nothing but, so here our aim is to develop a robotic application. So we have 4 variety of robot: unmanned aerial vehicle, underwater robot, and articulated robot, and mobile robot. So for every kind of robot, we have wide variety of parts. So robot having links, it has an actuator, it has a controller, it has a sensor, variety of sensors. So here, every functionality of robot is different. So it has wide variety of process. So we cannot integrate those processes in a single controller, single system. So we have to use we can have a different set of hardware system and hardware controllers. So those controllers or those systems can be individually controlled with the help of our program. So if you want to code your complex mobile robot or complex industrial robot, for each and path planning, for obstacle detection, for environmental perception, for each and every process, you have to write a code. So if it is a common code, you will face wide variety. You will face more difficulty. So we are dividing each and every process in separately, and we are integrating those process with the message. So by passing a message between those process, we can do a functionality of robot. So if you want to carry out a pick and place in industrial robot, so initially it has to detect an object. So object detection is one type, path planning is one process. We have variety of process. So each and every process is described as a node. We can call it as a node. So that is the functionality. So each and every functionality or process carried out using a set of software code. So between the so if any two software code is running, if there is any interlinking, those interlink is happen only on the passing a message. Okay. So here, by passing the message, we can make a functionality of robot. So if you want to make the pick and place, first initial thing is you have to detect the object, and then inform the robot to pick the object. So initially there is a camera, so it is a one type of process. It will detect the object. One camera detects the object, it will transform the object location in terms of transformation matrix, and it will my controller having another process. This process convert the camera transformation matrix into robot, that is the articulated robot transformation matrix. So camera is located in the some position, but my arm is located in some position. Okay, so if you want to move the arm, the arm motion is referred to the base of the robot, but the object is referred to the base camera reference. So you have to convert those object transformation, that is object position transformation matrix, into the robot, that is articulator arm we have. So in robot base transformation, you have to convert, you have to refer those object position in terms of base of the robot. So for that, the controller will take care of the transforming the position reference. Okay, so after the position reference is transformed, so after the position reference is transformed, you have to start the another process. So if you want to start one process after completing some other process, you have to make a communication between the two processes. Okay, so here I am saying that each and every process is a set of code. So that is a code means that is a set of program. Okay, so those programs are communicated, and once particular program is communicated with another program, client program will do a certain task. Okay, so here in the previous example I have given, so once transformation matrix, the reference is transformed by the controller process, the control process again initiate the motion planning process. So here motion planning process will do the will move the robot end effector to pick the object. So here we have discussed three different processes. So once a particular process is initiated with one process, that initiator process will do a certain task. After initiator process is completed, and it will initiate another process. So this initiation and completion will be discussed as a message. Okay, so the process is a set of code. So those set of code will do communication between each other with the help of some data. So that data is a message. So that is the message passing between the process. And package management we already discussed. Package management is nothing but here we have different number of processes are available for robotics. So for those robotic process, a robotic application are created under the particular common package. So those package having a dependency libraries and set of code for carry out some robotic task. So third point is it cannot be standalone. It need to be run on top of the operating system. Yes, the robot operating system is not as true operating system. It is a meta operating system. So this application, we can build an application on the top of the operating system, main operating system. So here robot operating system will create a similar features to the operating system, but it is not act as an operating system. Mainly act as an operating system. It runs on Unix based operating system. So in our case, the ROS runs on Ubuntu. So flexible framework for diverse range of robotic platform. Yes, here we have C++. So in the ROS, to develop an application for each and every process of my robotic project. So each and every process is written in terms of two different languages, which is widely used in C++ and Python. We have some more languages are available. So ROS will support more than two languages. So the commonly used language for language in the robot operating system is C++ and Python. So C++ compared to C++, Python is more easier. So here C++ having it is difficult to understand, and developing a code using C++ is harder. But Python, by comparing C++, Python is more easier. But we have some more advantages in C++. When we are writing some application in the C++, the speed of execution is higher when compared to Python. Okay, so in C++, higher speed to carry out a particular task, but in Python it is slightly lesser than C++. But for developing a robotic application in Python, we can easily develop. And ROS enables collaboration with world-class robotics to deploy their software right into your robot. So so here Fanuc is developing some kind of robotic application. Fanuc is one of the company which has wide variety of robotic application, and Yasakawa, ABB, and we have Universal Robot. So there are wide variety of companies are available. So they are producing wide variety of robotic application. So each and every company having their own software, So if someone is working with some robotic application, so they have to purchase a hardware of any kind of robotic. There is any type of robot. So if they purchase those hardware, so if he want to implement some innovative application in that robot, so he has to use those dedicated. He has to use their own software. So if you use their own software, it is difficult to modify their software. Okay, so the innovation is not possible if you want to use their own software. So for that, we are using a robot operating system. So robot operating system helps to integrate with any type of world-class robotic hardware, and it will provide the supporting packages. Using those packages, we can modify those packages. You can carry out the different tasks in the same readily available hardware. So if you want to make your own hardware, there are certain packages we can use it in the robot operating system. You can run your hardware with the help of ROS package. So ROS enables those type of collaboration with the world-class robotics, and it provides a long-term support. Here, long-term support is nothing but so here for kinetic version, recently we have support, but within this year or next year, the support will be closed. So after we have to move on to the melodic or noetic. Okay, so melodic and noetic having a support for some more years, and after that we had to move to another distribution. So every year the distribution was released, and it has advantage. It has wide variety of different advantages compared to earlier version of distribution. So currently, in this training we are using a Ubuntu 16.04, and Kinetic Cam is the one of the distribution we are going to use. So we are using a online ROS development platform. So for our hands-on training, we are using a RDS ROS Development Studio. The latest distribution is Noetic. So there are certain resources are available for learning the robot operating system. So the major widely used resources are ROS Wiki, and the Construct is one of the learning platform. So the summary here we have in robot operating system, we have to use Unix and ROS Kinetic, ROS, any type of ROS distribution. So those distributions runs on the top of your Linux operating system. You can prefer dual boot, or you can use the VirtualBox for running your robot operating system. And you should be familiar with the common basic Linux command. So ls list pwd. So while typing a pwd in the Linux operating system, you can view if you are presented in the current directory, you can view the path of those directory. And cd mkda, these are the command which is used in the Linux. And yeah, you should, so initially while learning a robot operating system, you should be patient, and you will be facing different errors. So you have to practice how to solve those errors and how to rectify those errors, and you should learn to solve the error while developing any project in the robot operating system. So here, these are the 6 companies widely developing their own project, and they have released their project commercially. So Embark, so Formwise, Sim, Built Robotics. So these are the 6 company. They are making a money in the robot operating system. So they have developed their product with the help of robot operating system. So currently, there are certain company which we are in which they have used robot operating system for developing their prototypes. So they are not releasing their product with the help of robot operating system. Just they are using robot operating system to develop their prototype before they are going to release their product. So by using a ROS2, there are certain companies releasing their product with the help of ROS2, since it is more stable compared to ROS1. So ROS1 is more stable, and they already rectified those error, those difficulties they have faced while using the ROS1. So ROS2 is more stable compared to ROS1. So ROS2 having less support compared to ROS1. So since most of the people's community engineers are working in ROS1, recently the researchers are moving to the ROS2. So ROS2, the major aim of the ROS2 is developing a product with the help of ROS2. So here, what is the robot? So here we have discussed the term robot everywhere while discussing in robot operating system. So robot, you should know the robot. What is meant by robot? Before going to develop an application or learn robotics, you should know how to define robot. So robot is nothing but, so here it is mainly used to perform a repetitive task. So if there is any repetitive task in environment or any kind of application, so those repetitive task is very difficult to carry out by human. So it is performed by the robot. So robot is the hardware which will perform repetitive tasks, and it can be reprogrammable. It can perform multiple functions. Okay, so by reprogram your robot, you can use it for different applications. So that is possible. So in every academic or every research person can define a robot in different manner. So we don't have common definition for robot, but robot having a 3 features: reprogrammable, it can perform repetitive tasks, and multiple functions. It can perform multiple functions. And the major parts of robot is, it is having a links, it is having a hardware part. Using those hardware part, it can perform a task, and it has common controller. So it is the brain of the robot, and it has sensors, it has memory. Okay, so it has sensors, controllers, and actuators. These are the three components plays a major thing in robot. So here, while describing a robot, you should have these three things. One is sensors, actuators, and controllers. So sensors, we have wide variety of sensors for different kind of application. We used to adapt different sensors for surveillance. For object detection, you have to use camera. If you want to detect an obstacle, you can use depth sensors and cameras. So if you want to here, if you want to control the robot, you have to use button switches. If you want to move the robot and how much distance it can be moved with the help of encoder, you can detect. You can, if you want to locate the robot using IMU and GPS, you can locate those robot. So for different kind of application, you can adapt different sensors and actuators. So here in robotic application, we have different different actuators are available. So link, arm. So in arm can be classified into arm having a different hardware. There is links, joints, etc. Okay. So by combining or integrating links and joints, we can call it as a, generally call it as a arm. And actuators act as a, here servo is one of the actuator, motor is the one of the actuator, rotor, and hydraulic motor, hydraulic cylinder, and wheels, wings. So if you're talking about unmanned aerial vehicle, underwater robot, you can use wings, propeller. So these are the actuators. And controlling part is yourself. You have to decide what kind of control you have to make, and with the help of common platform or their own in standard software platform, you can develop a controlling part. So this is called the basics of robot. This is the basics of robot. So while discussing robot, so mobile robot can be classified into different ways, and based on program we can classify the robot in different ways, and based on application we can classify the robot in different ways. Okay, so you should know some basics of robot. So the first one is merits of robot. So here we have general advantage of using ROS, robot operating system. So here we have 6 different advantage. So first one is thin, free and open source, peer-to-peer communication, multi-language, moving towards an industry standard tool, strong integration with third party. So first one is thin. So why we call it as a we have advantage, thin advantage. So it allows flexibility for coding. So if you want to develop a robot for particular application, so you can't use their own software for your modification. So if you want to do some modification in performing of robot, you have to develop a code. So the code can be developed in any type of language, C++, or Python. Okay, it allows different flexibility, and you can use predefined packages. So there are certain dependencies, packages are available. Dependencies in ROS term, we can use dependence. We can say dependency. General programming language, we are using libraries. So here we don't say libraries in robot operating system. We used to say dependencies. So by using dependencies and packages, you can write a ROS application. So for different robotic process, free and open source. So robot operating system is free and open source. So in across the universe, we have wide developers, ROS developers are available. So those developers, they have already developed a certain package for certain hardware application. So those package can be readily used by yourself, and you can modify. You can do some modification, and you can develop your own robotic application. So that kind of provision it has. And peer-to-peer communication. So it allows easier management of complicated multi-boards robots. So here inbuilt in robotic application, we have to detect an object. Okay, so by implementing advanced algorithm, there are certain camera having an inbuilt processor. So camera is having a one processor, and you have a central computer is a core processor. So you can make a communication between those processors. So you can have multiple board communication for developing a robotic application with the help of robot operating system. So that is possible. Peer-to-peer communication. Those communication is happen in terms of message. Okay, we can under the name of topic. So these are the terms widely used in robot operating system while discussing with the robot operating system. Multiple languages are used. So Python, C++, Lua, Octave, as we already discussed, Python and C++ having their own different advantage, merits, but we can't say which one is better. Okay, so C++ is having some betterness compared to Python. Python is having some advantage. Moving towards an industry standard tool. So here, if you want to, there are certain drivers and actuators and cameras are available. So if you want to use 3D camera, depth camera, you can directly integrate those depth camera with your controller. Okay, you don't if your controller is using a robot operating system. So if your processor is running Ubuntu and ROS, so you can use any type of robotic actuator or robotic hardware directly integrate with the ROS. So there are ROS drivers already installed once you have installed your ROS distribution. Okay, so you can directly plug and play your hardware device. And strong integration with the third-party environment. So here, if you want to model a robot, so if you are having a mobile robot and industrial robot, or you have already purchased, and those model is already deployed in your certain environment, third-party environment. So those environments are preferred as Orbis, Gazebo, and VREP. So these are the environment which is already used in the robot operating system. So robot operating system is integrated with these third-party environment. With the help of this environment, we can model a robot and we can do some simulation. And to carry out a robotic task, we can develop a program and just implement it in that environment. You can see the result. So how it works, and if you have done some modification in your program and you can deploy it in the corresponding third-party environment, you can see the modification. So that is possible. So VREP and Gazebo are third-party environment which is act as a simulator for robotic application. So you can use the simulator integrated with robot operating system. You can develop an application program in the robot operating system, and you can integrate with the Gazebo environment or VREP environment. You can see the result of your program in terms of simulation result. So now we came to limitation of robot operating system. So these are if we have robot operating system have wide more number of merits, there are some limitations are available. So as we already discussed while comparing ROS 1 and ROS 2, ROS 1 has having wide variety of supports. Even though it has wide variety of supports, there are some it has lose its stability. Okay, so here the stability of ROS 1 is very less when compared to ROS 2. So if you want to develop a real-time system, the ROS 1 is not suitable. There are functionality in the ROS 1. Those packages having it takes more time to run your process. Okay, so if you want to deploy your software created in the ROS 1 and into your hardware. So if you want to use those hardware dedicatedly worked in industrial environment, so if you want to use those hardware in the real-time environment, so it is not perform 100%. Okay, so the efficiency will be less when compared to their own software. So if Panuk is having a 6-axis robot, so if you want to do a pick and place application with the help of ROS, so if you want to implement those ROS application into the Panuk robot, so Panuk is having their own software package. Okay, so compared to ROS, program their own package is more efficient. So this is the one of the limitations of ROS1. So that is the application or program developed in the ROS1 is it is having more latency. So it takes more time to complete the process compared to industrial standard package developed for the particular part of hardware required to run the ROS on your robot. If you want to use the ROS in real-time environment, you have to adopt powerful hardware, that is the processor. You have to use the advanced processor, not useful when developing a novel application. So if you want to develop an innovative application, it is not useful. It is not more preferred. So ROS1 is not preferred. You have to move for ROS2. So if you want to implement a real-time system, which is an innovative system, you have to use ROS2. So due to its response and instability, you can't prefer ROS1. So, but ROS1 having a wide support, the developer support are available. We have documents, wide variety of wide documentations are available. So if you are facing some error or debugging is possible with the help of those documentation. ROS1 is having good documentation, but ROS2 is having less documentation compared to ROS1. The support is less for ROS2, but recently more researchers and more academic persons are moving to the ROS2, and they are developing a good documentation for ROS2. In future years, the ROS2 is having good documentation support and community support. And security issues are there in while implementing ROS1 in the industrial scenario. So the in case of security issue, we should prefer ROS2. So here, before going to work on robot operating system, you should know the file system, the level of concepts. So ROS concepts have 3 different levels. Files are managed in the 3 different levels: file system level, computational level, and community level. So community level is not discussed in this learning. Okay, so community level is nothing but you get the documentation or files or supports from the developer, which is available in the Google website. So that is the community level. And file system level, in the file system level, ROS will store all the files, necessary files and codes are in the first file system level. Computational level, if you want to develop an algorithm, those computations are done in your processor, advanced processor. So that is the computational level. So we will see the in detailed discussion about each and every level and 3 levels of ROS concept. So from this we will close the session, and in next class we will see the detailed discussion about file system level and computational level. After that we have the general terminology used in the ROS. So there is node, what is meant by process, parameter. So there are variety of terms which we are used while programming a ROS. So you should know those terms. So while you are clear with those terms, you can easily understand what we are saying, and you can easily develop a program.